All right, how we going? There we go. How's everybody doing today? I'm going to be looking this way a lot too because my chat is over here on this screen so that I can see you guys. All right, here we go. What's up, Matt? Hey, Ashton. Oops, this is lagged out. This way a lot too because my chat is over here. Whoopsie. All right. I think it stopped. All right, so it's Monday, I think, right? It's Monday. Some of you are working, some of you are at home. I'm doing both. So what I want to do today is I'm going to take apart an IAG oil pump. We're going to talk about their claims and potentially how or why they did it, and whether or not I think this is a good unit. I'm sure it probably is, but I haven't seen it in person yet. It's well, it's still in this box taped up, so get my stuff out of the way, and I'm just gonna get right to it. First, let's talk about the oil pump. IAG oil pump. Let's see here. Smooth this out of the way. Bring the chat back up. All right, there we go. All right, so I'm just going to read you what they say about this pump here. So this is their Stage 2 CNC ported 11 millimeter pump. It retails on the website for $450. Initially, you might go, holy shit, that's a lot of money for an oil pump. And when I first saw the price, I did too. But what I didn't realize is that Subaru has more than doubled the price of their oil pumps. They used to be around $100. Now they're like almost $300 for a factory oil pump. So the cost of materials and the decline of the dollar and inflation and all of that stuff has resulted in a more expensive OEM pump. So the pump they start off with has now become much more expensive. And so they still have to try and do all this work to the pump. I'm going to be interrupted here in a second. Psst, come on, sweetheart. Thank you. Gonna have to be, their initial cost is a lot higher. So then they have to do all the work to the pump and still make it affordable to you guys. So unfortunately, $450 is about where it's going to have to be unless the price of materials goes down and super lowers the cost of oil pumps because they're just not cheap right now. But yeah, they used to be like $105, and that was great. You could get as many as you want and just have a good time. Currently, I am doing a dry sump, and my dry sump is different than everybody else's dry sump pump because I'm actually using a little gear set, which you're going to get to see today inside the oil pump because that's what's inside one of these oil pumps. This one actually looks like it's a geocycloid, and all that really means is that the profile of the teeth is different. So you can have cycloids with all different kinds of profiles. Another one here, very similar profile too. This one's out of a Harley. Then you may have seen pictures of the ones in the 6MT. The 6MT that has an oil pump, it has a type of gear rotor pump like these. It's not as nearly as an efficient one. And that's really what changes with the design of these teeth. They're really interesting because the idea behind these is that there's very little sliding friction in the gear itself, so that when the gears come together, they're already at the exact same angle. So if you look, it's easier to see on this one maybe, but you have to look really close. There's like a spot in here that's actually straight for just a little teeny bit, a little bit of straight, and then the rest of it's curved. That little teeny bit straight is part of the drive surface between these two, and that's where when you hear gears talk about pressure angle is going to be the angle of the contact that the gears make. So this has a tiny bit of spur gear in it. The idea here with this little tiny flat section of contact patch, and then it has the rest of the cycloid, in this case a geocycloid, which again is just based on how they achieved these radiuses and what method they use. There's all kinds of methods they can use to achieve certain shapes. You can get all kinds of shapes that go together, basically is what I'm saying. And you could have ones like this where you see this outer gear it's flat on the outside here, almost. Not totally flat, but a very, very large radius. And then in this one, it stays round. See, these are all round. And this one's got a very squared off edge, where this one is not nearly as squared off as that one, right? So this one, it looks like a standard, I forget what kind of cycloid they call this one, but the squared edge, and this one's the Geo because it's got the rounder parts to it and everything else. So what they've been doing in oil pumps is they've been working really hard at getting their pumps to be as efficient as possible. And to do that, you got to have the lowest amount of losses in terms of the pump. And losses in pumps are many. And we're going to talk about those losses because that's what we're going to address with this pump, as what they did to minimize those losses, or what you can do to minimize losses on a pump. Not you yourself, but as a designer can do. So the main source of loss in a pump is just the amount of energy needed to drive it and compress. Well, not really compressing it, but you're moving the fluid into another volume, which then does create pressure. So this is a positive displacement pump. That's important because we're going to talk about what they're doing inside these. This is a positive displacement pump. The way it works is it moves this volume of oil. So what you see inside this gear right here, this void is pushed into the engine, and that's be important to understand when we get this thing apart. Shoot, that reminds me. It's in my car. Darn it. I should go get it. I will later. Okay. So, losses. Well, we have very, very small tolerances between these teeth. And so you're going to have some leakage in between those teeth and sections. You're going to have leakage between the side of this body and the body of the oil pump on both sides. The side of the gear and the body of the oil pump are going to have leakage, whether it's out the side or through here or across each other or whatever. You're going to have some leakage in there. And those are going to be primary losses that you need to address in an oil pump design. So we'll talk about that a little bit when we get the thing apart. So here we go. Let's unbox this sucker and see what we know what it kind of looks like on the inside, but let's see what IAG did to theirs. And let's just see how cool they packaged it, right? One thing about one product that I don't like, from an M company, they package their stuff really, really good. And I think it gives you like a false sense of quality with their product when they do that. Am I coming through okay? I haven't seen a single chat message pop up since I started. So I just want to make sure that everything's working. I'm not seeing any chat. So I'm hoping that that you guys can hear me and that this is working and that the chat's working, because I don't see anything. All right. All right, so here it is. Here's the box for the oil pump. IAG Performance Stage 2 11mm oil pump. Now, is there a Stage 2 and a Stage 2 CNC, or is the Stage 2 the same one? Okay, I don't see another listing for Stage 2 that's not CNC, so I'm assuming this is going to be the CNC one. So inside here we have a seal pack, the crankshaft seal and the O-ring seal that goes to the block. Looks like we have new oil pump bolts. That's pretty handy. I mean, I like the factory ones, but it's always nice to have new bolts. And these are not OEM bolts for the oil pump. This is it's a generic metric. It's a high grade though, so that's good. That's cool. So that helps everything look pretty instead of the factory ones being old and decrepit and worn out like you get in a lot of them. So they put it in a Ziploc baggie with here's the maybe the original Subaru oil paper. There we go. 480p though, huh? I wonder what's so crappy about the video quality. It should be 10 something. See if I can do anything to fix that. This is 1024 by 576. That's not very good. I've got a huge bit rate. I got a 51. Oh, here we go. Why did that go down? Let's try this. There's a little bit of a delay in that, but we will see if that helps. Okay, I've turned up the bit rate. Let me know if that helps any. Should take a second. All right, well, I turned it up. I don't know if it's still crappy or not. I just want to make sure that the actual video of the oil pump is good. I turned the bit rate up for both audio and video, so hopefully that helps. Recordings, can I pause? The recording quality is set to same as stream. Oh, okay, I don't want that. All right, so there we go. We'll see. Okay, so we're back here at the pump. Holy crap, there's a lot of paper. But the oil pumps do come in a lot of paper here. The cat's gonna love this. Okay, so what do we see here first? Well, first we got a nice little IAG, looks like laser etching there. They serialized the pump, which we saw on the wrapping. They also had that serialized. We see it's a Subaru Japan pump, factory pump. Got the 78 in the upper corner here. The 78 is what you'll see on the 11 mil pumps. They've marked all of the stuff that they have tightened. as you can see, to show the position. That tells you two things. One, lets them know if it's been tampered with, they get it back, or something is rattling loose. Now, obviously, I'm going to tamper with it, so we're going to get into that in a minute. So it's a brand new pump. Looks really good. Looks like Subaru's actually improved the quality of the casting. I haven't opened a Subaru pump in a while, apparently, because I don't remember them being this nice. But this looks like a very good casting that they've definitely improved over the years. They used to be really coarse and rough. We're going to talk about that, Eric. Eric just asked a question about the higher flow and higher pressure needed for an IAG, so we're going to talk about that. I can see here initially just by looking in that they have done the CNC porting here on the inlet and CNC on the outlet. Looks like they might even done a little bit to the port right here, which is really good. And so I'm going to show you the data that they provided and then the data from somebody else about oil pumps, not Subaru oil pumps in general. And then I'm going to talk about what I've been doing for the last almost 2 decades of these things and how it all jives and everything. So it's a good looking piece. All the sealing surfaces are good. Nothing's marred. They obviously took very good care of it when they were doing the machining. I don't even see, other than evidence of a bolt being tightened here and here, I don't see any evidence that it was even fixtured other than the bolt heads using the actual bolted spot. So wherever they fixture to, they must just use the factory bolts, which is good. There's no reason not to fixture with anything else, you know, when you have all these available bolt holes to hold it to whatever they fixture. If you look at the picture on their website, I think they showed a video of them CNC, and all these are all vertical, and there's a 5-axis going, they're going inside it. So looks good. They said they oiled them. This one feels a little, sounds a little dry, but we'll see when we take it apart. It doesn't need to have oil in it and how much oil and or grease is in it. Looks like my aspect ratio is a little funny. It looks a little taller this way than that way. Well, whatever. We're doing it. All right. Well, let's take it apart. That's the best place to start. This is my desk that I'm doing this on, so I'm gonna get some bubble wrap. I'll put it under the pump so that when I hammer it, I don't smash into my desk. And obviously, the bubble wrap is going to provide some cushion and dampen the impacts of the impact here. But best way to take these out is to use an impact like this. You want to use impact for a couple of reasons. One, you don't want to strip these screws out because they really suck to strip out. And if you strip them out, then they're hard to get out. So we're going to hope that today on live stream, none of these strip. That's why we're using this. Make sure it's in the loosened direction. And then make sure there's no cats nearby because they're going to wig once I start beating on this. All right. I like to hold a good amount of tension down and a little preload in the direction that we're going. And then you get your guts back. Any movement? Yep, I got a little bit of movement. These are in here pretty good. All right, so that one moved. I'm going to go in a star pattern because it's a 5. Makes sense to go in a star pattern. Make sure it's again in a tightened direction. Sometimes you can hit one and in the rebound, it'll change direction and you don't realize it and you hit it again and then you're tightening. So make sure that you verify it's in the loosened direction because they can and will rotate on you sometimes. So. This isn't the most stable work surface, obviously. So I'm working with what I got. There we go. It feels like there's Loctite on these screws as well, honestly, because after they've broken free, there's still some drag. So I wouldn't be surprised if they Loctited the screws in place because you really don't want these backing out. Subaru had a problem with a bunch of oil pumps, especially in like the 2010 WRX time frame with the oil pumps. The screws backing out of the back. I've had multiple cars on the dyno. I'm like, hey man, your oil pressure's low. And like, oh no, what's wrong? And judging by how it behaves, I was like, it really feels like the screws on the back of your oil pump have backed out. And sure enough, we pull the oil pump off and the back screws have backed out a thread or two and the rear plate becomes loose. And obviously that's far less than ideal. As you just dump oil pressure out. But yeah, it would look like this, and this plate is back here moving around. I'm gonna use the gun for these now. Now that they're all loose, and I'm not gonna strip them. Now that's interesting. Oh, there you go. There's a little bit of Loctite. Wow, hardly any Loctite though, but there is Loctite. Not much. That's good. It's good they didn't overdo the Loctite. Most of it stayed in the pump. Not much of it is attaching to the screw. So they did Loctite. Good job, IAG. I'm appreciative of that. Okay, I don't see grease in here. I thought they said they pre-lubed it. But I don't feel any lube in there. I could be wrong. I could have misunderstood. But I thought they were pre-lubed. But yeah, there's no lube in here at all. Okay. Oh, I see that they've done some work to the gears, it appears. Feels like they polished the gears themselves. And that's nice. That's a nice touch. I like that. That's why I wanted to show you that other pump housing I have. In fact, I might go get it here just a second. So it feels like they polished the gears. That's nice. Now what's cool about that, but also a detractor, is that if you polish the gears and you round the edges too much, you increase losses. Now, judging by their graphs from flow and everything, it was not an appreciable gain in any losses because it already has a lot more flow and pressure than the factory one. So here's a factory set of gears. You can see the finish is different. See how shiny these are and how these are a different color. So they've treated these gears. See the difference in color? And they've softened the edges here, where these are very harsh. Now what does that do? Well, you can look here, you can see there's grooves on this gear. And the backing plate, which again is in my car. I'm gonna get it. I'm just gonna go grab it. It'll take me 30 seconds at the most. Be right back. All right. Yeah, I read Loctite. Okay, so here's a 10. I have a used 10 with me here. Move my tools out of the way real quick. A second. So here's a used 10. Can we see that? Not yet. Right here. Okay. Pump design is super similar. There is a couple differences. They're not important for what we're talking about today. The gears are a little sharper on the edge. There's a lot of wear in here. And on this one, we got wear on the outside edge too. Trying to get this gear out. Usually they slide right out. But this one's about 30 degrees. Okay, so inside the pump body, you see there's wear right here, wear along this area, wear all through here. It's not a lot. You can barely feel it. You can still feel the factory machining marks from it, but you can definitely see a little bit of wear in the housing there. It shows it really good on the camera, actually, that band through there. And then the wear in this gear, just a little bit, right? Then the back plate here, you can again see the marks. See, there's definitely some contact here. This part is steel. This is an interesting piece because it's cast, and they just go and cut it, and it's coarse. Like, it is really coarse. You can abrade your fingernail on it. It's cut so coarse, which is interesting. I don't know if that's ideal or not. I mean, this coarse finish would retain oil and reduce the amount of surface area that this would have contact with, which might be a benefit. I don't know the answer to that one. But, so and you see this pocket back here. This pocket is 137 thousandths deep. This is actually part of the flow path to the pump, and we'll be addressing the concerns of that as well. Okay. So why did I show you that? Well, I showed you that because I want you to see the wear patterns on the pump and see if this softening of the edge help retain some oil and minimize that wear. That'd be the train of thought behind doing that. And one could hope that that's how it works. The other train of thought could be that doing that could allow a particulate of some sort, instead of being pumped through the pump, to move to the edge and get trapped and maybe even increase wear. I don't know what train of thought that would be correct. Obviously, they went with the better lubrication and less wear aspect of it, and I like that idea, and I'm all for trying that, and they've done the testing, so it must work, I would assume. I don't know if there's long-term testing of these pumps or not, but they did them both. I really thought they said they like packed them with grease or lube or something, but there's hardly anything in here. There's a tiny, tiny thin film on here at all. It's interesting. So one thing to note with the 11 mil gear, oh yeah, let me just show you that it's 11 mil. And show you what that means. If you don't know already, 11 millimeters is the width of the gear. So I'll take my little trusty dusty calipers here, put them in millimeters, and 10.95. That's theirs. Here's a factory 10.95. And then the 10 mil one, what do I do with it? Oh, it's in here. And right there. 9.96. So you can tell a 10 mil inner gear by this. You see the 11 has that. That's a quick way of looking. Not necessarily all of them are going to have that, but that's a right now on this table. Oh look, that's the 11s, and here's the 10. But you can also check that 9.95. If you can see that or not, there we go. All right. So here's some worn ones. Now this one actually I'm looking at now appears to be one that I think I ported a long time ago. Yeah, I poured this one a long time ago. So, this was a 10 mil. 10 mil is slightly different than the 11. Internally, if you look at the construction here, you'll see that this feed comes this little bump, and that's it, and stops. And the 11, you'll see, has a ramp. The 11 has a ramp going into that. Subaru went to the ramp with the 11. The 10 is just square and cut off in this, in here. See the difference again? Ramp and square. I believe the ramp to be better. In fact, if you look here, I actually knocked the edge off this 10 mil years and years ago. Man, this must have been a long time ago I poured this sucker. I knocked the edge off this 10 mil when I did the porting job to it. Also, there was a major ridge in here on the suction side that I ground down. I opened up the outlet here. Let's see if I can get on the camera. You can see how I got in with the Dremel and cutaway here to increase the size of this opening as it comes around that corner. Because what they do is they just drill it straight in and have this casting. And it was a very, very narrow spot right here to get all the oil flow out of. And so by opening this up, granted this was not one of my better jobs I'm looking at now, but it did open up quite a bit and increase or decrease the turbulence that the oil would go through, the sharp angles that to go through to get out the pump. I also ported this hole here, see if I can get in there or not. Not just in this direction, but I went like this inside of it, and I add a little bit of oval to it and increase, almost like I was porting a head or something, trying to make this a rounded corner instead of having a really thick edge to it. IAG looks like they touched that a smidge in theirs as well when they did their porting with their 5-axis going down, but they didn't round it nearly as much as I do. You see mine's really thin right there. I definitely had a lot more rounding. So they also ported, well, they hit this area with a little bit. this casting is a lot nicer than the 10 mil casting that I had before. They used to have a really big casting ridge right here, which they've obviously gotten rid of. It's a lot nicer in there than it used to be in the past. Before there was a big lip in there, which is why on this one you see I ground that down. They did this whole inlet, and I don't know honestly if that provides any help or not. I assume that it would help from this point to this point, but doing all of this has no purpose that I can think of other than making it look pretty. I don't know any reason why you need this whole area here ported, because there's nothing flowing through there. All the flow goes from this here where it sucks from the block and then it goes into the pump. So from here to here, the porting would make a difference in reducing the inlet restriction. And so looks like they addressed most of the things that I previously addressed in my hand porting, only obviously with a much nicer job, being that it's CNC'd and everything, and that's nice. They enlarged this a little bit here, like I was doing before. Only a little bit though. I personally would go further. This newer casting is thicker through here, so there is more space allotted to actually get, because this is the back side of it, right? Where you can actually port it some more right here on this outer edge and get a little better flow out of the pump that way. So how does this pump work? Let's go back a little bit, because I know I'm talking to you guys like you know how this works. Okay, first thing you need to put in correctly. So we have a dot. Dot goes facing you. As you can see, this ridge here goes down inside this groove. Dot facing you. Now, the dots don't have to line up because this inner gear has one less tooth than the outer gear. So that dot, now you see it's matched up. But if I turn this a rotation, now it's off. And it'll continue to be off every tooth. Now, this is something that people do when they make gear sets in general, in just cars as it is, because they want to keep the same tooth from hitting the exact same tooth every rotation. They want it to oscillate. So you'll see gear ratios where the gear numbers are odd, or the ratio is 411, 373, right? Those odd ratios are very common because they want to make sure this gear hits every gear. And the idea that if there's a fault on one of these, it doesn't hit the same spot over and over and over again on the same gear and cause a bunch of excessive wear. It lets it like distribute through everything. So how does this work? Well, from the front, the engine rotates clockwise. So from the back here, it's going to be counterclockwise, right? So what we're going to see is counterclockwise rotation. So the way this works is the crankshaft is through the center of this. There's a flat on the crank, and crankshaft speed turns the pump. Now, as the pump rotates, you will see here we have a closed volume, and as it rotates, this volume becomes larger and larger and larger, right? Now we're seeing a larger volume. So this large volume here, from nothing, I open up a volume, so it creates a low pressure to draw fluid into it. It gets to its maximum size right about here at the bottom, right out there, it's maximum size. And then it seals it off by having the flats on this side, right here, and on the other side of the housing. And then it goes to the discharge side where it starts to squeeze that volume and push the oil out of the pump. And so you see this volume gets smaller all the way to here. So this pump is discharging oil all the way to the top. So this whole band, this whole side, is part of the discharge process. And as such, you see that there's a channel from the top all the way to here. And the same is true for the suction side. It starts to grow here. And so this channel has oil going up into it, counter to the rotation of the gear. I want to add that. Then flows up into it, gets trapped, and pulls out. Or then pulls through and then gets pushed out through here. Any questions on that? No, okay, not yet. All right, cool. So it just does that over and over and over again. And what's really cool about it is that the pump gears are held by the housing here, and this one's held by the center on this little center board, but also the crankshaft. And you can hear there's some play in there, and there needs to be, because oil needs to get into here, needs to be able to lubricate the gears and all of that. And then this center, there's a tight spot in here every time I rotate, right there. It drags every time, right there, right there, right there, it stops, look at that. I force it through, and it rotates, and there it is again. And it rotates. There it is again. So I don't know if I got a piece of dirt in there or something was in there to begin with or what, but it just drags a little bit. That could be me though. I could have contaminated it with some dirt. Anything in here? Piece of, a little bit of Loctite or something maybe. I would definitely be cleaning it before I use it. Will not be getting a warranty if it fails because I've already fucked with it. Okay, so now, what does all this mean? What does all this mean? Okay, in a previous video of mine, I discuss that the oil pumps don't have flow issues, they have pressure issues. And people are like, what are you talking about? Well, this gear is more than adequate of supplying enough oil to the engine. The 10 mil is more than adequate for the single AVCS, and honestly, it's probably enough to do the dual AVCS as well. And the 12 is more than enough for the dual AVCS. And I tell people all the time, don't just default to a bigger pump. Don't, because your oil demands haven't increased any, don't default to a bigger pump. I always recommend throwing some shims in it, which we need to check and see their shimming job too. And polishing some things, polish the relief, which I believe they do as well. So let's get to that too. And then pack it with grease and put it together. That's what I tell people all the time. Just shim it, pack it, polish the relief, and call it good. So why do I say that? Well, first off, the relief is integral to the pump body. Now, the relief being integral to the pump body is super handy. It's very convenient. It creates an oil pressure regulator and an oil pump all in one housing. And that's great. For OEM manufacturer, nothing beats that. That is, you know, it's just like the mass airflow sensor and the intake air temp sensor. They're in the same housing. They're two separate sensors in the same housing. Well, this is the same thing. It's got a pump and a pressure regulator in the same housing. It minimizes the amount of different things that you need to do the job. The issue with it is that this relief valve does not reference atmospheric pressure. This relief valve references suction pressure. So when people see their pressure dropping towards red line, for some reason they assume that means the pump is not large enough. And that's not the case. The reason the pressure drops is that the reference point of this relief is the suction pressure. And it's simple physics to know that if I want to move more fluid through the same diameter tube, I need to have a greater difference in pressure for that to happen. The oil pump provides that difference in pressure. So the suction side pressure in this oil pump goes down with RPM. If I need to move more fluid that weighs the same through the same size hole, I need to increase the differential pressure across it. That differential pressure is felt at the relief, at the reference side of the relief. Are you following me here? So I can go and increase the size of the orifice, which means more flow for the same pressure differential, which is what we've done. IAG has done. They've opened up this suction side some. They've taken out some material in here. They opened the suction side up. And a lot of people go to aftermarket oil pickups, bigger ones like the Killer Bee or IAG setup or whatever. And so now I've increased the orifice size, which means to flow the same amount through that, I need a lower pressure differential. So right there, I increase flow at the same differential, which means what? Well, it means that when the relief opens, it's not opening, I won't say it's early, in the RPM range, or it's not referencing as low a pressure. So what I'm saying is, in reference to atmospheric pressure, if I have a restriction on the inlet, the relief is going to see that as a reference, and it's going to reference 75 psi from the outlet of the pump to the inlet of the pump. The inlet of the pump, if it's at -14, then I'm only going to have 60 psi up top, or 61 psi to atmospheric. But if I reduce the restriction on the inlet side, and that differential pressure need to move the same amount of volume goes down, then that means it would be closer to atmospheric pressure. So it's going to only be -10 or -8 in the suction side of the pump, which means now the engine, I see that difference. I get that 6 PSI back, or whatever it is, based on what I'm doing here, okay? So it isn't a flow problem, it's a pressure control problem, because the pump is more than capable of flowing enough. So again, when you see the decline in pressure as RPM goes up, it's not because the pump isn't flowing enough. It's because the relief is opening, because it sees that suction pressure as a reference, and it's taking a volume of that pump's output and recirculating it through the pump. Right? This is a positive displacement pump. It's going to move a volume of fluid regardless. It's going to make it happen. It's either going to have extremely high discharge pressures or it's going to have extremely high bypass flow. It's going to have one or the other. You can shim the relief a ton, make the pressure 150 psi, and if it does that, that means you have very little bypass flow and more flow into the engine. Or you can remove a bunch of shims or lower the spring rate, and then the pressure is going to be 30 psi, and that's going to give you a ton of bypass flow and a little bit of flow to the engine. So now, if we look at IAG's claims here on their website, I'll bring these pictures up for you. I have a little slideshow here. They show flow versus RPM, and they show pressure versus RPM. Now, these gains are not because the pump just magically flows more. It isn't like this 11 mil now all of a sudden became a 13 mil or anything like that. What they've done is they've reduced the inlet restriction, which is what I used to do as well when I ported these guys. They reduced the inlet restriction, and they did it by porting and increasing the size of the oil pickup. And they've raised the bypass pressure, which means they've reduced bypass flow. So they're basically saying this pump moves X amount of oil, I'm going to make it harder to open the relief, which immediately forces more oil in the engine. So I can simply take an oil pump without changing anything, add shims to it, and I will see an increase in flow in that oil pump. So if I add 2 shims to a super oil pump, I will get a marked increase in flow rate because the bypass flow has been reduced. And that's really important to understand, that it isn't like there's a bunch of voodoo in here. They've increased the bypass pressure, and that's the biggest increase in flow. And then they've reduced suction pressure, which by porting the inlet and changing the oil pump stuff, the inlet tube itself, and that increases flow because again now we're bypassing less. And then they've improved the outlet of the pump where it leaves the pump body and goes into the engine. That reduces the differential pressure across this pump as well. So again, it's not magic, it's not voodoo or anything. It's just a really nice job. It's a really good way of doing it. They've done a very nice job with it. But overall, it's a very simple system. And what you're doing is overall, like I said, it's pretty easy. But for them, they've done such a good job. They've done the CNC on it, and that's machine time, that's setup time. They've measured the clearance in the gears to make sure that the gears have the right distance between them, between each other, between the gears and the body, and all of that. So they've done a really good job with the pump. They Loctited the bolts. You saw they were difficult as shit to get out, so they don't back out during operation. The only thing I think that they failed on was not adding lubricant to it. Some people don't believe in it. Some people do. I do 100% believe in lubricating the pump beforehand. You don't need to pack it full of shit, right? But putting a grease in there, a slightly thicker grease, so that air can't easily escape the pump or get by all the blades and everything is really important, because that means that your engine will prime faster. Speaking of priming, the best way to prime is to first remove the filter, have an oil pump with oil or grease in it, and then prime it. Make sure there's a pan under where the filter is. Turn it. Take like 5 seconds tops, and you'll have oil coming out that filter hole. Then put the filter on it, and you keep turning the key. What'll happen is, with that oil filter gone, you don't have the restriction of the engine on the discharge side of the pump. You won't have any issues with air binding. With the grease on the gears and the filter off, in just a couple turns, you'll have the pump full of oil. You throw the filter on, you hit it. You need like 10 to 15 seconds tops to prime the engine. A lot of guys, also make sure the spark plugs are out. A lot of guys will prime the engine, they got everything together, they sit there, just lay on the key, and 30, 45 seconds go by before the darn thing primes. And if you do it with plugs in it, you're doing it wrong. You're just saying F you to all your bearings. Don't do it with plugs in it ever, okay? So again, grease the pump, put it on the engine, put the whole thing together, leave the filter off, key it 5 seconds or so. You'll have oil coming out the oil fill. Put the filter on, then do another 10 to 20 seconds, whatever. You're gonna see pressure go faster than it has ever gone in any other situation. Once you get a prime on it, and you know that all your oil gathers are full, then throw the plugs in it and give it a fire. I got some messages coming in. Let me double check what we got. Do you think you can build a dry sump that deletes power steering instead of the AC? Yes. Yes, I believe I can. So, yeah, I believe that I can. It might not have as many stages because that area has less room. Right now, I have a 3-stage pump that goes in the AC location. It's being built right now. And then the AC, I probably can only put 2 stages, or where the power steering, I probably only put 2 stages there. I don't know if I could put it. Now, granted, I am on the front side of the pulley, so that gives me another 1/2 inch or so of room to add stuff behind it, but I don't know if I would be able to do nearly as many stages in that position. I'll have to check it out at some point. Lubricant may be a shelf life thing. Yeah, I mean, you can't hand lube it if it's Loctited shut. So Southern Motoring Solutions says lubricant may be a shelf life thing. Some assembly lubes tend to gum up. However, the instructions should be clear to hand lube it immediately before install. Yeah, not really. Yeah, there's some oxygen, in the pump and trapped in the bag and the wrap and all that stuff. But there are plenty of extremely stable greases that you could use to do it. Even using like the driven assembly grease, that's what I would use. I would use the driven assembly grease and just wipe a thin layer, on this surface and then on the surface of the gears themselves. Just run it through and just give them a little bit on there, put it on there. Now, if you're lubing these before assembly, grease has an ability to trap dirt. So you have to do it in a clean area. You can't be sitting in your shop, in the middle of a bunch of crap, some dude's grinding next to you, blowing shit off, and like that. You gotta do it in a clean environment. Now, IAG has clean rooms. I've seen their stuff. They got some really cool shit going on over there. So they've got some really good areas to put all their stuff together, and it's really impressive space. I don't know if you've ever seen it. When I had MPS running many years ago, many of you don't know what the fuck MPS is. We were one of the leading shops in Subaru engine builds, and I did a lot of custom stuff, a lot of experimentation and all of that. And one of the biggest things that we had that nobody else in the area really had, or anyone else in the industry had, was an actual clean room. We had a room that was dedicated to assembling engines. Dirty parts were not allowed in. Like, nothing was allowed in that room unless it had been cleaned and gone through. It was a whole different area. It had its own ventilation system, right? And IAG has that now. They have even like way cooler shit. They have some of the coolest measuring equipment. They have some of the best. They just have a lot of the best stuff. It's really impressive. And I know in just like the last 5 years, they have pretty much completely overhauled their entire engine program. And it's really impressive. The machining, the machines themselves, their measuring tools, the air gauging setup, their clean rooms, like, it is really impressive. So like, IAG could definitely grease this appropriately, and in a clean environment so that they're not getting dirt in there. But you start getting dirt and grease, and we talked about what I talked before, particulate in here, messing things up. Now, that being said, there's no filter on the inlet of this pump. Okay, and this is really important. There's no filter on the inlet of the pump. So what does that mean? That means anything you subject your oil to or your PCV system to, you're subjecting your oil pump to. Okay, a lot of guys go atmospheric on their PCV system, unfiltered. Don't do it. If it's unfiltered, it's getting in the pump. At some point, the dust, the silicone that you see in your oil samples and shit, it's from poorly done PCV systems. If it gets in the oil, it gets in the pump. And then you're talking again, particulate between the gears and the housings and all sorts of stuff. There's no suction filter on this. There's nothing. There's a strainer on the bottom that's wire or a small orifice to stop large chunks of paper or plastic, or the little seal that you had on your oil that you poured in. You just broke it off and pushed it in, you hit it, and it flops off and goes down your fill tube, right? It's just got a strainer on. That's it. Small particulate from the PCV system being sent to the atmosphere goes in the pump and fucks it up. This one, this nasty pump, probably had an atmospheric PCV system on it, honestly, because of how much dirt is in it. If your system is sealed and filtered, then you're going to have a nice clean interior to your engine. You have a nice clean pump. Your pump's not going to deal with much crap. What does particulate also fuck up? The relief. Particulate also fucks up the relief. That thing's tight. And my battery's low. Now I'm ratchet. There it goes. All right, so this one again has sealant on it. In addition to the sealing washer that comes on here, this aluminum washer here, its whole purpose is to seal this. I think it also, the thickness affects the preload on the spring. As you can imagine, if I took this washer out, I'd have more preload on the spring. One of the shims fell out. It was stuck to the bottom of the spring. Usually just stick a finger in there, a little pinky. Slide this like that. Very nice. Now this is something that we did at NPS long time ago too. We would polish, like I said, you polish the relief and the bore just a little bit, and this slides really nice. Obviously, I can't provide you any of the data other than saying it's extremely smooth. From the factory, the reliefs are kind of gritty. They kind of, in there. And people used to ask us, like, oh, well, why do you do that? And it's just to minimize the chance of it binding, getting cocked in the bore a smidge, locking up. And when these reliefs stick open, bearings go bye-bye. It's pretty much the way it goes. So the best way to fight that is to do a good job polishing. Now, you gotta be careful, because if you overdo it, yeah, see how shiny that is? Look how shiny. So they polish that. I don't have any I do have a factory one in my garage. I used to buy them because you could buy almost every part for this pump separately. So I have some in there. They don't come with that kind of finish on them. It's a very gray finish. So this has been polished. It's really nice. The bore itself looks like it's either they polished it or it just came nice in this newer casting and they just worked on this part. Obviously, I don't know what they did other than I can tell this has been polished. And it's really nice. It doesn't feel like it's too much. And that's a concern. If someone doesn't know what they're doing and they go too big with this, what they do is they make this smaller, and then it increases how big of a piece of material can get between the valve and the body. So it's important that this isn't overdone. Now, this one is lubricated here. This relief was lubricated. I feel the grease on it. It definitely was lubricated. It feels nice. And it doesn't feel too loose in the bore. I've seen people do it and they're loose in the bore. And again, that means if I have gap, it means a particle will get between that valve and the body and stick it. And once they stick, pressure goes to shit, and so do your bearings. So this is very nicely done. We can see they added some shims to it. How many shims you add depends on what spring rate you get. I don't know what they did for their spring rate and all of that, but it's a very nice job. I have been getting so many spam calls since I registered a new website. It's silly. So if you do that, make sure that when you register with it, you put a different phone number on there. Because I screwed up and put my personal number on there, and it's been spam calls all day long. Hello. This is Dominic. I'm kind of shitty. I don't know why you're calling me. I don't know where you got this number. I don't know who the fuck you are. This is a personal number, and I don't have any way or any reason for you to call my personal number. So thank you. I'm a dick. I get 12 calls a day now. So fuck those guys. All right. So Well, I got some dirt inside here now because the Loctite was on my finger. So obviously I got to clean this up before I put that together. I see some more shims in there. I'm just gonna put them all in here, put like that. Just start this, and then I'm going to clean it all before I put it together. But I don't want to do that and then get a bunch of shit stuck in this pump and redo it. So yes. So anyways, they did a great job with this pump. I really like it. Obviously, it's a bummer that they're $450, but like I said, the cost of the factory pump has gone up so freaking much. There's not much you can do. There's just not much you can do to compensate for that if you're trying to make something better from the factory pump. So they still have to have all of the pay the personnel, pay for the machines, pay for the time, and all of that stuff. So they did a really good job. What's going on? Someone said, oh, yeah. That's what you're talking about. What's up, buddy? Hey, I just did. You're live. Yeah, I didn't realize that. So, yep, I'm sorry. I will recover a few things real quick for people. Steven. Yep, I need a production assistant. So here you go. Now you can see it better. I'm sorry, I had that graph showing. Here's the spring. There's shims. Here's the relief valve, and you can see it now in that camera. I was saying how shiny it was. They did a good job. Oh, you know, I got more light right here too. Check this out. Woo. So they did a real nice job polishing that. Doesn't look overly done, and like I said, doesn't feel overly done. Fits in the bore really nicely. And here you can see, and actually if you look inside here, now there's no graph in the way. See that right there? That's the flow path. So if you follow this hole, this goes to the discharge of the pump. So the discharge gets vented back to the suction here. So when the pressure is high enough, or this pressure is low enough, that it overcomes the spring pressure, pulls that open, and then oil flows and bypasses into the pump. And so by increasing spring pressure, we reduce bypass flow. And that's the idea behind that. Is there anything else that I had shown for you guys that I screwed up? Hey, I got a donation from Cartech and Toys. Hey, thank you very much. I appreciate the donation. Eric saved us. Yep. Yeah, I gotta check chat a little more often. Yeah, it's the graph and the seatbelt chime are ruining your stream. Seatbelt chime. Was that Eric calling me? Is it the seatbelt chime? What do we got? Eric is the man. I wonder why he called back twice. I was like, he knows I'm streaming. Oh yeah, that's why. Because I'm stupid. All right. Is there any questions about this now that you guys can see it again? Very nice, clean pump. Very dirty pump. Oh boy, Matt's telling you guys all about. Oh, someone's here. Oh, finally! Finally, my custom-made hoses have arrived. I can start making cooling mods again. Son of a bitch. That was just the worst experience with FedEx ever. And I'm still going through another worst experience with FedEx ever. Where they sent all my custom cans back to New Zealand. Fucking idiots. So yeah, my hoses just arrived, so I can start making kits again. That's really good. Hey, Eric, you're listening. I can get more kits again. And I got 2,100 hoses out there. And I have like 700 tees. I have 12,000 clamps. So I'll be able to make some kits now once again, which is good because it sucks to put all that money out for parts and not be able to finish a project, which also means more money towards dry salt and everything else. So that's good. Shim thickness. I'm not going to tell you, honestly, because that's IAG's business. I'm not here to give away the exact dimensions and measurements of everything. I'm just showing you generally what they did, why it works, and why this is a good product. I'm not doing it so that you guys can just copy every single thing that they did. So I'm not going to tell you shim thickness, to be honest with you. So you can never have enough hose. Yeah, so I'm not going to tell you guys that. I think I revealed enough of what IAG did in this teardown. Hopefully not too much that they're mad at me for it. But yeah, I'm not going to tell you how many shims are in there. I mean, here's 3 of them, but I saw more in the tube, so I don't know how many it came to. Subaru shims them, right? That's something to keep in mind. Subaru shims them from the factory, and they shim them to achieve a certain bypass pressure based on the spring they put in there. They have a couple springs. Springs have manufacturing tolerance differences. The bore of this pump, where they end it, changes the preload on the spring, right? If they drill the hole for this relief, where the relief valve sits, the thickness of the relief valve changes a smidge in the casting, where the spring sits. All those things are going to affect the final relief pressure. So they put them on a jig, they check the pressure, they shim them to achieve the target pressure. So each one is going to have a different number of shims from Subaru. Generally, you see 1 or 2 shims from Subaru, because each one's going to be, you know, a fixed thickness. These look like a standard number 10 washer is what I believe they are, which I think is, I don't know, what are they, 35 thou or something like that, 30 thou? This one's 38 thou. This one's 40 and a half. And it's just a number 10 washer, right? It isn't parallel ground. It's not a precision ground washer. It's just a generic number 10. That one's 40. So I got 39 and a half, 40, 40 and a half, you know, on those 3, plus whatever else they have more in there. I see some other in there. Okay. So what pressure do they ship it for? I don't know the answer to that. That one's stuck in there because there's a oil in it. You see here in the bottom there. See down there. Anyways, so I don't know what pressure they have it shim for. Maybe they tell you in their literature. But each one's going to have a different amount from the factory. Like I said, it's generally 1 or 2. I've seen them with 0. It just depends on how good the spring is, how well they cut the ends, what's the overall length going to be, how deep was that whole machine, how thick was the valve relief body, and all that kind of stuff. Does this aluminum washer come slightly thinner or thicker? All those things are going to affect the final position of this spring, the resting position, and therefore affect the bypass pressure. And so they do it, they shim it to get the right pressure, they send it out. And so what do they do at IAG? Well, they probably add more shims. I assume that they didn't come with 4. They might say in the literature if they add shims or not, I don't know. But they add some shims. They, like I said before, reduce the bypass flow, which means more flow to the engine. They reduce the bypass, or the inlet restriction, the outlet restriction. They do a nice job treating these gears with whatever system. It looks almost like it's a REM system, honestly, looking at it. They could just be tumbled. It could be a wet tumble with a stainless or ceramic, a ceramic media. I don't know what they did with them, but they've obviously been treated, and they look nice. They look nice. They feel nice. They spin relatively well, obviously, except for when I got the shit stuck in it by taking it apart. And yeah, I'd say the only thing is they probably should have a little more grease in this. Maybe the other ones come with more grease. And I just got lucky. That's typically what happens. If anyone's going to make something and something's going to get missed, it's going to get sent to me. That's how it works. K1 rods are being made wrong for fucking 8 years. And I called them like, hey, this is the wrong dimension. And they were like, holy shit, it is. So they had to change their stuff. I called Cosworth. They had engine plates. They were making the wrong thickness. I said, hey, you know that these aren't engaged in the head studs the right way? They got the wrong, like, what are you talking about? And I said the measurements. They go, holy shit, you're right. We fucked that up. We didn't carry a 1. Manly had some shit made wrong. They had their cranks done wrong. So there's a lot of stuff that happens, and for some reason they get sent to me. And so if there's going to be an outlier, chances are it's in my inventory. That's just the way it is for me. So I don't know what else to say about that. So I'm assuming they have more oil in them. But other than that, yeah, I said to clean this guy up, put it back together. Hopefully I answer any questions you guys have. You guys can see that I think it's a good solution. It's done very nicely. They did a very good job on everything. The only thing I would do is increase oil and increase this radius right here. Personally, if it was my own design, I would increase this radius a little bit right here to help it get out of the pump a little better, and then oil it. And then I would analyze a bunch of running pumps. They have a Spintron there, so they have the ability to do this, which is really cool, which is probably how they got the flow rate in these in the first place. The FA pumps have been seeing a lot of cavitation on this ramp. So I don't know if they have or not, if they've checked for cavitation in this area, but they didn't touch it. So I don't know if that means that this ramp is the right angle. To me, it looks like it's a little on the restrictive side. I don't know, but the FA pumps are, and what you'll see is in this casting, you start to see little pits form. Material starts to go missing as the vapor pocket expands and collapses, and that action generates a hammering effect. If you think about the oil there, if there's a vapor and then there's oil and there's vapor and then there's oil, the weight of the oil is hitting it. And so you get this hammering effect in the surface, and you start getting these imperfections in right here on the ramp. And so I'm sure that IAG has done it, but if they haven't, I would say run a bunch of pumps for a long time, guys, and see if you see any pitting here. Because if there's pitting here, you may need to alter this ramp angle. Since you've increased the flow and all that stuff, you may need to alter that ramp angle to keep it from cavitating there. Now, that being said, also I want to add, by reducing the restriction here, they will also reduce the cavitation there. Because if it takes less pressure to move more fluid, then that means the pressure that's seen on this ramp is actually going to drop alone. So once that drops, then that will minimize how much, I say drop, but it's the negative, becomes less absolute. Then that will reduce the amount of cavitation that you would see on this ramp. So in essence, it's possible just by reducing the restriction, they've stopped cavitation from occurring on this ramp. I don't know. Obviously, that's something they would have to check and see. Can you call CP and tell them they forgot to offset the pin? Yeah. Yeah, they will tell you there's no reason to do that at all. That's a good joke, by the way. Thank you, SMS, for that. CP pistons, they do not offset wrist pins on their pistons. They say that they've done a lot of research and there's absolutely no point to doing it, which I find absolutely asinine, because every engine manufacturer on the planet does it, and engine manufacturers never do anything if it doesn't help in some way or another. They never spend more money. Why would you want to do that and spend more money if you don't have to? So, do you think you can run a dry system below freezing temperature? Well, thank you, Mr. Physical, for the, or Fiscal. Oh, it's Fiscal. I always thought Physical the whole time. Fiscal for the $10 donation. Thank you very much. I appreciate it. All that stuff that you guys give me goes towards R&D of projects, being like the dry sump and the cams and the cooling mods and my battery tie down. Of all the stupid things, I got a battery tie down, I know. But it's a quality adding device, let me tell you. A quality of life improvement device. So, can you run a dry sump system below freezing? I don't know why you couldn't. The only concerns that I would have would be the distance between the pump and the sump. Obviously, oil is very viscous with temperature. If you were to, I mean, you can do this with anything. You can look up any oil brand that you want. Almost every single one of them has a technical documents and specs, like an MSDS or an SDS sheet. And in that, it will tell you the viscosity at various temperatures. Viscosity is a funny thing, because a 40 weight from one manufacturer and a 40 from another will have a different viscosity at 100 degrees Celsius, which is where one of the measuring points. Often you will see it at 40 C and 100 C. Sometimes you'll see it at 0. That's where they'll check the viscosity of their oil and give you those numbers, and you'll see that some of them are different. And also a 5 W40 at, say, 0 might have a viscosity of 300, but a 1540 would have a viscosity of like 600, or even higher than that at the low temperatures. So if it's a race car, chances are you're probably running like a 50 weight. And if it's a 1550 like Mobile One, now we're talking about a viscosity of like 3000 at freezing temperatures. And that would be difficult to get into the engine regardless of where the oil pump is. But are you going to be racing that? Probably not. So I don't know the answer to that. Obviously, if something's freezing and you're getting water in there, that'd be a concern. My dry sump setup, the way I'm doing it is I'm trying to get a configuration where the sump is in the engine bay, and trying to get it to where it's really close to the height of the pump and not really far down somewhere, because you want the pump to have to lift the oil up to get to it and then get it to the engine. So I don't see why you couldn't. I just see that you have the same problems with oil viscosity regardless of where the pump is getting its oil from. It isn't like the oil is or should be leaving the pump and you have this big air void from the tank all the way to the pump again. It should stay with oil in it, because there isn't going to be a vacuum break in the pump where all of a sudden there's much air there and all the fluid leaves. So I don't see it being an issue with getting oil to the engine any slower than if it was a factory wet sump system. So obviously I haven't tested that. I haven't, my sump's not even done yet. It's at the machine shop right now being cut. They finished the main shafts last week, and they're working on getting the material for my separator plates that go in between the stages, and they started cutting the stages, I think, this week. They're starting to cut the stages this week. So I haven't tested any below freezing environments, but it isn't like oil turns to a solid or anything. And also, you should be running the viscosity that fits your operating conditions. So if you have an oil cooler and you're in freezing temperatures, it's really easy to keep your oil cool. You don't need a 50 weight, right? You're not going to need a 50. You're going to need something thinner than that anyways, which will help. And with modern oil technology, there's no reason why you couldn't have a 0.50 or 0.40 or whatever to run it. So that'll minimize how much thickness you get or increase in viscosity you get as temperature drops. And that's one thing to know. People say that the first 0W, or 5W, W means winter, and that's the viscosity when it's cold. And that is the biggest hunk of shit I have ever fucking heard. I don't know where that came from or why people say that, but that first number is an index, and that index tells you how thick the oil gets as temperature drops. So a 15 gets thicker than a 5 or a 0 as temperature drops, but it always gets thicker as temperature drops. So I don't know, don't ever think that for some reason your oil is a 5 weight when it's cold and then becomes a 40 weight when it warms up. That's just not the case. What else we got? What power level do you thinking about pump upgrades? So pump upgrades have nothing to do with power. Really, nothing to do with power. It's all about oil film stability. That's really it. It's about oil film stability. If you put way too large of a pump on there, let's say you go to a 12 mil and the engine's not going to take a 12 mil. So you can have a whole bunch of bypass flow. Now you're taking a quantity of oil from this pump and you're putting it through the bypass and you're just sitting there doing circles with it. And you're shearing that oil down even more than it has to be. You're aerating it up because it's going through all these different pressure changes. It's going to go from a high to a low suddenly through the relief. Any dissolved gases that are in the oil, that as it gets heated up through here, they're going to be more likely to come out as they pass this interface again to a low pressure area. So any dissolved gases go bloop, right? So like if the oil pump gets heated, the oil gets heated in the pump a little bit. So you add energy to the oil by pumping it. So now if I have an entrained bubble, it's not a bubble, it's a gas that's dissolved in the oil. I pass it through here, I raise the pressure on it, I raise the temperature on it, and then I pop it through the same section, you get to a low pressure again. The chances of that gas coming out of solution are greater than they were without doing it. So if I start circulating that same volume of gases and stuff, and also if I'm adding more and more dissolved gas and I start getting more bubbles in here, I start getting a very bubbly, aerated oil recirculating inside of here, which we don't want. We don't want that at all. The air has way less inertia than the oil does. So the air is going to have no problem going out this relief and hanging a right turn and coming out, whereas the oil is heavier, is not going to want to hang that more than 90-degree turn out of here either. So the air is more likely to make it than the oil is. So I can really start recirculating a bunch of air inside here and aerating the oil and really messing it up. And when you add aerated oil into your engine, you have reduced film strength. If my oil has no gases and no bubbles, and I'm pushing on it, oil doesn't want to compress, the bearings are protected. If I start adding air bubbles in there, now I have little areas where the oil that's being compressed can occupy. right? I've put sponges in there now. So if I have a bunch of air in the oil, I can squish it, the air can compress, I can get it to where I can get contact between the bearing and the crankshaft or whatever. So I don't want aerated oil. So don't go too big on a pump. Don't go too big on a pump because you don't have to go to a bigger pump on your stock engine. But what does help is reducing bypass flow, which is what they've done here. They've reduced bypass flow, reduced the amount of times oil circulates in here, reduces the chances of air to leave solution, reduce the chance that air that's left solution is retained in the pump for a while, right? A bunch of things that are good about that. So if you have a car that uses a 10, don't just buy an 11. It isn't like you're going to fix anything. You can create issues with that. I had one guy, airplane guy, who put a 12 mil in his NA 2.5 Subaru thinking it was going to be better. And he spun the bearings in less than 100 hours of operation. And I got the bearings apart and you could tell it was just aerated, sheared oil. The surfaces were messed up. There were pockets everywhere because the bubbles were just going into there. No problem. Right in the engine. So don't run too big of an oil pump. So, so what I'm saying is with the oil pumps, reducing bypass flow is great. Increasing pressure is fine. Ensuring you have enough pressure at high RPMs is critical, and ensuring that you have sufficient film strength at high RPMs is critical. Best way to ensure those things is reduce shearing, reduce aeration, maximize pressure, right? So upgrading the pump, don't go bigger in size, but to go with something like this, it's almost any time, really. It's an improvement to the pump. It's an improvement to the pump. But it also means that your pump size has more room. I guess is what I say. Like your 10 will do more. Your 11 will do more than what it did. Also, as you increase oil demand, you need more flow, right? Well, how do you increase oil demand? Larger bearing clearances increase oil demand. Different turbochargers that have different size orifices may use more or less oil to them. That increases oil demand. Going to more AVCS increases demand. If you go from a single to a quad, then you're going to need to upgrade that oil pump. Things like that, things that use oil to drive things, those will need more flow. So if you have an engine that's got king main bearings in it for some ungodly reason, and you're just dumping most of your oil out the mains, then you're going to need a little more flow, whether it's enough to shim it or to go to a bigger size. You could do that, but typically shimming it for the right size pump that came out of the engine is adequate. Doing this is a benefit, a huge benefit. Again, reduce the inlet restriction through the CNC porting, reduce the outlet restriction through the porting, improve reliability of the bypass, higher bypass pressure, reduce bypass flow. All of those things really help. So as Eric said, is cheap insurance. I agree. It's a good idea to do it. So especially if you're going to higher RPM, right? The faster this thing is spinning, the lower this pressure is here. The lower this pressure is here, the greater the chance of cavitation, the greater chance of the more bypass flow you have, all of those things. So yeah, especially if you're going higher RPM or you're living your life a quarter mile at a time where you're high RPM the whole time, then definitely you're going to want something like this, because you definitely will want to have a more stable oil film provided by a better assembled oil pump. Connor Williams with $9, $9.99. Thank you very much. Do you like NA builds or turbo builds? I like turbo builds, but don't get me wrong. NA builds have their place if they have more than 4 horizontal cylinders. I don't think any EJ NA build is worth 2 squirts of piss, honestly. The amount of money you spend in trying to get an EJ to make power NA is obscene, and then the end result is you don't beat a stock long block from any turbo ever. Like it makes no sense. That being said, I did an NA build on my Corvette because I wanted a big nasty NA build on the Corvette that barely idles and sounds ridiculous and revs to $8 grand, and I did that. Unfortunately, it didn't make as much power as I wanted, and I thought about going back to the drawing board and changing some more things on it. But then my buddy Igor came across the blower, so now it's going forced induction again. I really wanted to put ITBs with a gigantic carbon fiber scoop on it. This company has a really nice setup, and I really wanted to put that on the vet. But that would only give me like 30 horse, and I wanted 130 horse, so I bought the blower. So now it's gonna be blown, and I'm taking out my hog ass cam that's in it, and Igor's gonna put it in his car because he wants an NA built in his, and then so he's gonna get my big ass cam, and I'm putting his medium sized cam with his blower in my car. For 6 cylinders, I mean, it's hard not to like turbo, right? Turbo's it's easy power. It's just easy fucking power. I have what do I have? I own 2 cars that are not turbocharged. 2 cars that are not turbocharged. The 2020 Blazer, which is a great fucking SUV, by the way. That thing is really awesome. I know it gets a lot of hate because it's called a Blazer. The top doesn't come off, but the top hasn't come off Blazers in years. And the Blazer was always the sporty version of the SUV, and this one is absolutely sporty. It rips. That thing moves out. And it's comfortable. It drives great. Anyways, enough of that. That's not turbocharged yet, and my SVX isn't turbocharged yet. And then my Corvette's supercharged. So I don't really have anything that's not forced induction. My BMW, it's got the B58 in it. That engine's fucking amazing. And what's a little known fact is that the short block of that B50, I'm sorry, not the block case was made for the diesel, and then they also use it on the turbo gasoline car. So that case is made to handle some serious fucking cylinder pressures. It's closed deck, and it's made for the B57 diesel. So it's capable of some serious poop, and that's why the guys with the Supras and the 40 series engines in the BMWs are having such good luck with them. Those things are just tanks, so they can do some serious shit. That's a great motor, and I wouldn't want it to be NA. That thing's so awesome, turbocharged. Oil choices and viscosities affecting the build. Oil choices. I run Schaefer's, and I run Liqui Moly. Schaefer's recently came out with a 040 for gasoline engines, so I'll be using that exclusively again. I was using their 540 for diesels, which is good, but I wanted a gasoline oil, and they just recently came out with the 040 for gasoline stuff, so I'll be going back to that solely. I had gone between Liqui Moly and Schaefer's back and forth for the 540. The issue is Liqui Moly oils don't meet SM technically. I mean, they supposedly do, but the additive package is different, and the EJ requires old oil. Plain and simple, the EJ requires old oil. It needs oil with more zinc and more calcium and more boron and all that shit in it, because it's basically a flat tap motor. It's like the last flat tap motor, one of the last flat tap motors out there, and it just needs a better oil. I think the B58 might actually be flat now too. I gotta double check to see if it still is. So I like the oils that have the SM and that kind of stuff, and nothing really meets that. Liqui Moly is definitely deep in the SN plus category, which is close, which is good, but the Schaefer's I think still meets the SM as well, and that's why I've been using that for so long. I typically run a 40 weight in the lowest I can get on the other side. So if I can get a 040, I run that. If I get a 540, I run that. That's typically what I personally run, unless I'm on the track. And again, oil viscosity is very much about your operating oil temperatures. It's absolutely critical to understand that. If you don't know your operating oil temperature, then there's no point in trying to custom tailor your viscosity to your engine, because it's absolutely critical to know what your temperature is. If you don't know it, then go by the manufacturer's recommendation or go a tiny bit thicker if you run it hard. So If your manufacturer has a towing spec where they say, you know, if you're towing with this, run this weight oil, then you should run that on the track. So for Subarus, typically that's a 40 weight. Unless I don't have a good oil cooler and I'm running a long track day, then I run a 50. Just because all I have is the factory oil cooler, that thing is going to be toasty warm. My oil temps are going to go up quite a bit more than they normally would, and the oil's going to thin out. And so the operating temperature on the track of a 50 weight is going to be the normal operating temperature of the oil. Driving it around on a 40 weight, it's got the same viscosity, and that's important to know. So, do you ever do any hot? Oh, before I change from that, also, you don't want to go too thick, right? It's important, like I said, to know the viscosity or the operating temperature of the oil so you get the right viscosity. The reason for that is the rest of the engine is made for 30 weight, right? The cams in their journals, the ABCS system, all that stuff is made for an oil viscosity that matches the manufacturer's recommendation in a normal daily use. So you do know that if you have the factory oil warmer / cooler, that your oil temp is going to be around your operating temperature within 20 degrees. Plain and simple. If you're driving around every day, it's going to be within 20 degrees of operating temperature. Okay, that's what the 30 weight was for. Now, if I start increasing my duty cycle, more power output for a longer period of time, temperatures start going up, then I need to go to 40 because it thins out. And if I, you know, get it even hotter or I have bigger bearing clearances and I need to go to a 50 on the track, well, that's fine, except that my cams now are under lubricated until the oil gets hot. So it's important to realize that there's more to the engine than just the main bearings and rod bearings. The oil's got to get between the pistons and the skirts. It's got to get in the cams. It's got to get, you know, on the individual lobes, all the buckets. It's got to do the buckets in the bore and the head, right? They're oil fed. They got to spin. They got to lubricate. So you can't just go crazy thick and be like, well, it gets hot. Well, the rest of your engine's not getting enough lubricant. So that's important. It doesn't. At least last I looked, Matt, I went through the specs actually just yesterday, the day before, and I did not see anything that covered SM. They had SN and SN plus, but no SM. I think it's 10 cars. Might be 11. Nick asked, do you ever do any Honda stuff? K and J series are impressive. Yeah, man, that K series is pretty sweet. It's easy power. No, the answer no. I don't have any Hondas. I don't do much Honda stuff. I do some tuning on it. It's like I don't do a whole lot of 4G stuff too. And honestly, the reason that I got so into Subarus is because everything else was so fucking easy. Tuning a 4J, or 4J, a 4G, tuning a 4G is stupid easy. Like, it's not even a challenge. And making them fast, not a challenge. The first 4G I ever built made 800 wheel horsepower, like 6 years. Like, there's no challenge to that. It's not a sensitive, finicky engine. And the Ks are the same way. They're not hard. The heads flow so well. The geometry is normal, right? It's a stable, strong engine made by Honda. It isn't a challenge, and so I don't tend to do this. Plus, most of the things are front wheel drive. And if I want something that's all wheel drive, I gotta get an SUV and then swap into something else. This isn't what I want to deal with. And then most of that shit's automatic, you know, that kind of stuff. So no, I don't do much of that. I've tuned a few, but there's just no challenge to them. And the Subaru stuff is infinitely more challenging. So I've always kind of done the Subaru stuff. But I do miss V8s and I miss rear wheel drive. And so I bought a Corvette, my CTSV, and all that stuff because I wanted to get back into that again. Because that's where I started. I started with a GM. Pretty sure, like, okay, there's that. But yeah, so as far as Honda, I don't own any Hondas, and so I don't do much of that. I try not even do much of the bug eyes because the EJ205 is becoming like the B16 of the early 2000s. It's just fucking everything and everywhere, and it's probably beat to shit or whatever. It's so rare that you find them in nice condition. And there are some. I get some of the shop occasionally. They show up, they're really nice. But also a lot of it is, you know, what do I want to subject myself to as well, right? Because it isn't fun to sit in someone's car that smells like shit. It's not any fun. I don't run the AC on the dyno because I don't want to change the way the engine's heat soaking on the dyno. It affects the air temps, affects the coolant temps when the fans kick on, that blows air in the MAF and all that. So I try not to do any of that shit. And So, yeah, if the cars are really nasty and dirty and stinky or whatever, then it just isn't fun to sit in there when it's 120 degrees in the car and deal with that. It just isn't fun. So I try not to do it. Plus, I really enjoy making parts. I really enjoy designing parts and making parts a lot. Any other questions? I mean, we probably do this all freaking day, but as you've heard, my phone keeps ringing. Like the seatbelt chime, is that what someone said? Any other questions I missed? Let me look at that real quick. Eric said, no balls, I won't. I'm not sure he no balls me for, if it was for the ITBs on the vet or not, but he's right, I won't, because I'm not, because I bought the supercharger. So you say, at any point's best modify. Yeah, I believe that modifying the pump is good. Oh, that's what I want to say. I'm sorry. I had a picture. I thought I put it on here. Was it in the I thought it was in the slideshow. Let me see if it was in the slideshow. I want to show you this picture. Let me bring it up. This one. I don't know if that was in the slideshow or not, but I didn't explain what it is. So, Engine Masters, Season 6, Episode 9 or something like that. They took an oil pump, they did the high pressure, then they did the high volume, and then they did a billet pump on this engine. And we probably did, Matt. So if you look at there, you see that the peak gallons per minute went from 4.9 to 6.1. And the pressure went from 54 to 76, right in there. Now, that's exactly the same results as IAG shows you with their graphs. They're showing you that when you reduce the bypass flow, more of it goes to the engine. And so I wanted to show you guys that it isn't just IAG that knows that. It isn't just me that knows that. These guys knew that as well, and they showed it, and they proved it again in their testing, that when you reduce the bypass flow, you get more pump flow through the engine. Matt said, I wonder why you didn't mod my pump when we built your Subaru. We probably did. We probably did mod your pump. I told Nick how to do it a long time ago. I don't think he ported it, but I know that we polished the relief and added shims to it. But the reference to the episode of Edge Masters. Oh, well, there you go. Yeah, it's a good episode. Eric, it says weak that I'm not going to put the ITBs on the vet. I know. I think the heads I had on there are really good heads. They're CNC ported, 243 head. They flow really well. Not quite as much on the intake side as an LS3 head would flow. A ported LS3 head would flow, but they flow pretty damn good. But they do have 30%, 35% more flow on the exhaust side than the LS3 head, a ported LS3 head has. And that's one thing, if you look at the difference in cathedral cams versus rectangle port cams, the reason they're different is because the cams are made around the fact that the exhaust port flow on the early heads, on the 241s, the 243s and all those, is way more than the exhaust port flow on the LS3 heads. And the balance is different between intake and exhaust. The LS3 balance and flow is a little better for NA power. The increase in the intake flow and the reduction in exhaust flow is actually a little better because it increased exhaust velocity, which aids in scavenging and exhaust-driven intake charge. So it's better for NA. But when you go force induction, the 243s that I have are better force induction because you now have way more volume leaving the engine than than you had originally was NA. So the heads I have on there are better for forced induction than they are for NA. And so if I was going to do an ITB stuff like that, I would put some ported LS3 heads on it and put the ITBs on it. And if I was going to stick with like a centrifugal charger, I would keep the 243s on there with the fast manifold and all of that. But right now what I'm doing is putting ported LS3 heads on there because the blower I got's for an LS3. And we're putting the ported cathedrals with the crazy exhaust and intake flow on the shop Corvette with a Pro charger. So that one should be a lot of fun. And maybe at some point we'll put the ITBs on something. I really want to do the ITBs really bad. The issue with that is there's no filter. There's no filter. And I am not Cletus. I am not someone who easily runs unfiltered air into an engine. That is not something that I do. And I mean, I've seen what one small little dust particle it does to a cylinder wall. One time I was putting an engine together and I was turning it over as I finished putting the rings in, and one chunk of something got in that cylinder bore, and in 3 strokes I turned it over and looked, I had put a gouge in the cylinder wall. And it was one tiny little fucking piece, and it had put a groove in the cylinder wall that you could catch your fingernail in, like, significantly. So I am not one to put unfiltered air into an engine. That's not my jam. I don't like to do it. Flat plane ITBs on S3, yes, I would love that so much. I would absolutely love that if I could do that, or if I could afford it. Well, I mean, I could probably afford a crank because I bought a $4,000 Callie's crank for the Corvette. And then I also bought a $2,000 Callie's crank for the Corvette. So I have a $4,000 Callie's crank for the Corvette and a whole motor that I built. I bought an LSA blocks. I wanted the piston oil squirters. I got custom JE pistons I could use with oil squirters. I had Manley rods custom made for the engine. I got a $4,000 billet Callie's 8 counterweight crankshaft for it. Like, I had this whole thing built, and I realized I got way too much fucking money into a C5. And so I abandoned that project and went for a cheaper build, only to later throw a fucking blower on it anyway. So I don't know, man. You know. But yeah, I would absolutely love to sell that bottom end and then start over and make a flat plane, get a flat plane crank, and do that. That'd be super awesome, for sure. I would have to use the screen though, because the tack on the Vet only goes to 7, and if I did that, we'd be going way over 7. Any experience with Cerakote piston coat for piston valve tops and combustion chamber on the head? Yes. Micro Slick? I don't know about Micro. Oh, yeah, they're Micro. Right. Yeah, so a place in Auburn does all that stuff, where they coat the crowns and coat the skirts and all of that. It works okay. I use piston crown coating as much as possible, because it reduces how much shit sticks to the top of the piston. And I like that a lot, because the less buildup I get, the better off the engine is going to be. So I definitely use coated crowns whenever possible. I also like to do clear anodizing hard anodizing of the piston ring grooves in the pistons. That's shit. Every OEM piston is hard anodized. Like, you might not know that, but if you looked at a factory piston, you see that dark band around the ringlands. That's hard anodizing. They've hard anodized those ringlands to make them harder and last longer. So because the ring sits in there and moves around and squishes and goes up and down and rattles and moves around in there. So they make that surface harder so that it doesn't wear into the piston. So I absolutely hard anodize the ringlands whenever I can, whenever it's available. JE offers that service, and I do it with them all the time. Micro Slick, yeah, we did it before. I didn't like it. It came off really easy, and I wasn't a big fan. But JE has their perfect skirts, which I do like. I do like the perfect skirt a lot. Broadcast platform, good chats by LS Heads, originated from Rear Morrison. Darren Morgan. Okay. I'll look him up sometime. Yeah, so, oh, and then the chambers. The chambers, absolutely. I mean, anytime that you can reduce heat that's retained in the head and reduce the buildup in the head or on the valves, you're winning. So it isn't like you're going to see an increase in power. You're not like, oh, wow, I gained 20 wheel by having these coatings on this. Not going to happen. It's just going to be more of a longevity and a potential reduction in knock tendency as the engine is operating, especially over the life of the engine, because you get less deposits on there and a more even heat in the chamber. Knock originates at a hot spot near peak cylinder pressure, and the last thing you want is another hot spot, you know, to have knock. So if you have the chamber coated, then you have a more stable temperature profile across the chamber, which means a reduction in hot spots. How about the thermal barrier benefits? Barrier to what? I guess maybe coolant and oil, maybe a tiny bit, but you know, I don't know if it's gonna make a big difference in that. I mean, it's gonna keep the piston a little cooler, so it helps oil a smidge. It's gonna transfer slightly less heat in the engine, but really, like the amount of heat that's going in is so steady. It isn't like a whole lighter under a coated piece of plastic for 10 seconds and stop. Like, oh look, it didn't melt the plastic. Yay, right? Like, if it's a continual heat load, it's gonna soak through. It's just gonna soak through. You know, like that's what's gonna happen. It's continually, and eventually, it isn't like it's got something telling it stay cool all the time, right? It's eventually gonna get hot. It's gonna take a little longer, and it might help when you're doing short bursts on the drag strip where your EGTs are really, really high for a short period of time, and then you're not. So I can see on the drag strip might provide a little more benefit in that regard, but on the track, I think overall, on the track in the long term, it's not going to matter. Your first two laps might be better, but then, you know, eventually it's all going to be fucking hot. Yeah, there's a slight delay. I think it's about 10 or 12 seconds from the stream to the chat and when you guys see it. So I apologize for that delay. I think I covered everything. Anything else, gentlemen? 23 concurrent viewers. Not the most popular chat, but I mean, it's a good subject. I think we cover a lot of oil pump stuff. Talk about oil pump construction, operation, ways you can improve it, how good of a job IAG did on that, how they and other people have reaffirmed what's been believed to be true about oil pumps, and I think that's it. I know that I have a long task of cleaning all the gunk and Loctite out of this before I put that together again, lubricate the gears and toss it back in, and get it going again. This will go on my next motor. I'm building a 2.3 again because I miss it. I have a 2.5 in my car right now, and actually that doesn't even run right now because we're doing turbo kit on it, but I missed the 2.3. And then after I have the 2.3 for a couple years, I miss the 2.5, and then I miss 2.3 again. It's just a cycle. So the idea is, I think, to have one car that's already a 2.5 and one car that's 2.3 and have them both and enjoy it. But yeah, I definitely miss the 2.3. So I'm gonna put that in there. We got a G35 900 going in a very low factory location, rotated location spot, but low, like real close to the axle low, maybe a little too close to the axle low. The up pipe's about the same length overall in that location, but the down pipe is shorter and has a lot less of a hard bend on it. So it's a much straighter, longer sweep bend, so that'll help with a bunch of stuff. And it gives us a ton of room up top for air, water, intercooler, dry sump, oil sump, tank, hint, hint, and other things that I'm doing over there in that area. Does oil weight affect miles per gallon? Yes. Yes, oil weight does affect miles per gallon. Jason Brown, summary. I think Jason just showed up. I think is what happened. So summary, Jason, is I disassembled an IAG Stage 2 CNC oil pump. I did a visual evaluation of it. What I believe they did to the pump, what they did really good, what they did pretty good, where I think it might even have a little more room to improve. Why I think it's a good investment, and then why all that stuff works. Yes, I'm glad that you like the setup. I'm at home, right? I'm at my desk. I'm not holding my cell phone in my face, walking around the shop, you know, that kind of stuff. IAG does stuff to the gears. I don't know how much we missed, but here's an IAG gear set. It's a factory gear set that's been treated, and then here's an OEM. You see the color difference, right? So they definitely tumbled this or rimmed it or something. Like I said, it may be in their description. I don't recall if I've even looked at the description and checked that. Let me see. CNC ported. Maybe they tell us what it is, and I'm just being stupid. La, 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 la. Features. Here we go. 11 mil oil pump. Yep, we know that. Shimmed and rem polished pressure relief valve. Okay, so they rem polished the pressure relief valve. That makes sense. And they shimmed it like we talked. Measured, blueprint, and assembled. Yep, packed assembly lube. This one wasn't. The relief was, but the gears weren't. Ship ready to install required hardware. Yes, it did. It had an FD hardware pack, which had the seals, the seal, the O-rings, and new bolts. CNC ported. Yep. Maximize flow and pressure, reduce cavitation risks. Hey, I talked about that. Without even reading another thing, I talked about the cavitation. Test to outperform other company available pumps. Yep, does that. Designed for single and dual extension. Okay, great for stage built in it. Yep, fits all AJ. Okay. So they did mention that they rim polished the gears. They say shimmed and rim polished pressure relief valve, but it doesn't say rim polished oil pump rotors. These look like these are also rim polished. So I don't know if they did, or maybe they did this for a little while and they were like, fuck that, that sucks, or what. But these appear to be rim polished as well. But that's not in their description. Front crankshaft, seal O-ring, zinc plated bolts, pump. Yeah, there we go. So that was their website I was reading, obviously. IAG are out front for build. I don't know. That's a really generic question. So I like both companies. Both companies have good products and they're both run by good dudes. So I can't say one or the other. I guess it probably just depends on what you're trying to achieve. Yeah, I don't know. I don't know. It's not tier 1 for the win. Oh, answered Bradley. Yep, yeah. I trained the guys at tier 1 to build engines. I'll train Nick at tier 1 to build engines. So Nick builds them for tier 1. And he's very, very, very picky. And I have improved the processes over time and the specs a little bit over time. And then, of course, the improvement in piston technology and everything from JE helps a lot. Bearing-wise, we try to avoid king now. We just had too many issues with the kings. So we do either clevites or ACLs. Preferably clevite. We would love to lose clevite, but right now there's just a shortage of those every freaking where. So not a big ACL or king fan, but the ACL mains are definitely better than the king mains, and I prefer the clevite bearings for everything. I think IAG uses ACL on their stuff, I think. For the rods, they're both fine for the rods, but for the mains, I definitely prefer the clevites or ACLs. Yeah, it just depends on what kind of build you're doing, I guess. You know, I don't think Outfront has a Firelock setup, so if you're trying to do 1,200 horsepower, I don't think you're going to get it with the Outfront stuff. I could be wrong, but I don't think they have a Firelock setup. I think, didn't IAG like pioneer that? You know, I think they did, so I don't know. Use them on my old 22R. Oh, on the clevites, yeah. Yeah, right now there's definitely clevites for other brands, but for some reason the Subaru one is definitely short. Actually, that's not true. So the LS stuff is short too. I've been trying to find the right clevites for my LS builds and stuff lately. It's been hard as well. I remember when Out Front was a tiny shop and went apart, churning out Subi engines primarily for dune buggies. That's correct. Well, let's see how they've grown. Yeah, dune buggies are a blast. I actually tuned a few of them before. You know, and every shop out there has had issues in the past. You know, with machining or make mistakes. When you do as many engines as IAG or Out Front, there are going to be mistakes on occasion, that kind of stuff. And I think the biggest difference is really how they handle it. You know, everyone's going to make a mistake on occasion, just plain and simple. There's going to be errors, and it really boils down to how they handle it. Whether or not they tell you to go fuck yourself, or whether they're like, oh shit, yeah, we'll help you out, you know, just send it back, or whether they're like, we'll give you a 20% discount or whatever, that kind of stuff. You know, that level of accountability is important, but also so is the level of accountability for the customer, because customers fuck shit up a lot too. You know, they mess up in assemblies, do things improperly, way over gasket seal something and get stuff in oil galleries, all kinds of things. So obviously the people that make their own product are going to think their product is really good, and they're going to put it out there with pride and sometimes too much pride, but pride in knowing that it's good. And if they fuck up, they're immediately going to think, well, what'd you do to my thing? What'd you do to my engine? You know, I know that's how it was with Craig at MPS, because he spent so much time doing everything, and he had, you know, processes for everything. And he was very, very, very picky. And when one had an issue, you know, the first thing he was like, well, I didn't do anything wrong. And that's just a natural response, you know, from anyone who does that when they put that much time and effort in that kind of stuff. So it's just whether or not that company is able to say, well, maybe I did something wrong, really is the difference. So Out Front does Athena gaskets. Yeah, I mean, the Athenas are good, for sure, but and I guess they last longer. I don't know, but they don't handle the pressure that the Firelocks do. So I don't think that that's a necessary comparison. I think we're talking different horsepower targets there. Yeah, so healthy oil pressure. That's a difficult subject because it depends on a lot of stuff. One of them is, where is the oil going? So if you look at the flow paths of oil in the engine and where you're measuring the pressure, we'll just say you're measuring it right here on the outlet of the pump, and you got 85 pounds right there at the outlet of the pump. What is that telling you? Is it telling you that you have plenty of oil to the engine? Or is it telling you there's a restriction somewhere that's making the supply pressure be really high? Right? And that's the issue if you just don't freaking know what's going on inside the motor. Because I could easily say, oh, look, 100 pounds pressure. That's fucking great. And spin every bearing in a matter of seconds. Why is the pressure high? Or why is the pressure low? Is the pressure low because the mains are really large and they're dumping oil pressure out, dumping oil out of the side of the mains, and it's not getting to the rods, and then you actually have low pressure to the rods? Or is the oil pressure low because the rods are a really decent large size and the mains are tight, and you just put oil into the rods, like a ton of it, and it's flowing through the rods really well, but the mains are actually too tight? Is it low because you have a low relief set point? Is it low? Like, there's all kinds of reasons. Like, you don't know necessarily what's going on in the engine. That's why it's pretty important to have the right clearances and know, you know, what's going on. I know that when I put king bearings in an engine, my oil pressure at idle makes me uncomfortable. I know that when I have king mains and I have oil pressure in the teens at idle, I get uncomfortable. Is that founded? Maybe not. Is it because I'm dumping tons of oil pressure out the side of the mains? That's what I think it is. And that makes me uncomfortable. The king main bearings are not very round. And almost no bearings are very round. Let's just start with that. So if I look at a rod bearing, the rod itself is very round. The hole the bearing sits in is very round. But then the surface of the bearing is not. It's tighter in the middle and looser at the parting line. And that's because as the engine is operating, there's a stretch and a squeeze effect that's going on. If you pull on a circle, it's going to get skinnier. So they plan for that pull to squish the bearing down some right there and bring the clearance in. And apparently King did the same thing on the mains, more than the other manufacturers that I've seen. I've seen the other bearing manufacturers come out and the bearings are way less egg-shaped than the King's. The King's like this, the other one's like this. They're still bigger at the parting line. They're just not as big at the parting line. And the bigger they are at the parting line, the more oil pressure you lose in that area. So to me, my evaluation of the King bearings is that their excessive eccentric shape to them has caused extra oil to dump out at the parting line a lot. Their early ones, when they first kind of came to the market, like 2010 era, 2013 era bearings, they had way too much oil going to the thrust bearing. They had tons of grooves in the thrust bearing. And so they were just dumping tons of oil to the thrust bearing, and they were losing pressure that way as well. And if you look at their progression of their thrust bearing over the years as they've changed, and they've changed the main bearing for the Subaru like 5 fucking times. And it every time they've changed it, there's less oil ports on the every time. Less. It went from 10 to 8 to 6 to 4 or whatever 4 or 6 like it is now. So like it's dropped down a bunch because they just dumped way too much oil through the thrust bearing. King calls it their elliptomax feature or something like that. Yeah. Yeah, I mean, that's what we're talking about. We're talking how it is an elliptical shape and not round. And like I said, on a rod bearing, that makes sense. And I guess technically on a Subaru main, it might make sense. I don't know. See, the rod is getting more of a stretching effect, and the Subaru is getting a fucking pounding effect. It's a slightly different way that the bearing moves under pressure, I think, in those two situations. And I don't know if increasing the clearance at the top of the parting line is going to aid in that any. I don't like that at all, to be completely honest with you. So, like, this is why I don't like it as much. With a rod, the pressure from the piston is always at the top of the bearing. It doesn't put pressure on the parting line, right? It puts it in the center and the top of the bearing. On the mains, that's not necessarily true. It moves around a little bit. Yeah, it's mostly center, but it still moves a little bit as the crankshaft goes through the throws and the rod's pushing everything. There's still the force moves up a little bit, moves down a little bit, and it has a wider application range in the main bearing than you do on the rod, because the rod changes direction. So the bearing moves with the force, but the main bearing doesn't move with the force. The main bearing is stationary. And yeah, I don't like how elliptical it is on the mains. What else was I going to say about that? Yeah, I just don't like it. So that's my reasoning. It could be wrong. I changed from 1550 to 540. Operations dropped 5. Wow, I'm surprised that's all it dropped. Honestly, going from a 50 to a 40, I'm surprised that's all it dropped. Now, why did it drop? That's the question, right? Well, I put thinner oil. Why did it drop? Well, I said earlier that pressure and flow are related. And if the pressure drops at the same flow rate, then, or the same supply, then what's that mean? That means you get more flow to something. You're getting more oil through a part. Is that more oil pressure through the rod bearings? Or is it more oil flowing out the side of the mains, not getting to the rods, or what? I don't know the answer to that. But if your main bearings are good at the right clearance and your rods are the right clearance, then what you've done is you drop pressure because you increase flow rate. You got more oil going through the engine right now. And that's the other part of that oil pressure thing that I try and tell people that to keep in mind is that if I have a pump that's moving 6 gallons a minute and I put 50 weight in it, I'm going to get 80-something pounds. And I put 40 weight in it, I'm going to get 60-something pounds. I put 20 weight in it, I'm going to get 30-something pounds. Right? The flow rate increases as that pressure drops because I'm still turning like the same, what am I trying to say? This gear is the same size, right? I said that before. That amount of oil that's trapped in there is that amount of oil. Now, there is a slight increase in internal leakage I will lose a little bit of flow from the pump, a little bit, because there's still a little bit of internal leakage. But overall, like, it's still moving almost the same volume of oil. And whether it goes to bypass flow because of the restriction downstream or whether it goes to the bearings depends on the weight and everything. So if I had the exact same engine and I change all the viscosities and the pressure drops some, chances are I've increased the flow through the bearings. And potentially through leakage paths, like I said, the side of the mains, the side of the rods, a little bit internal to the pump. But it's only a little bit, you know, it's only a tiny, tiny bit. So pressure is just such a, I think pressure is overstated and overrated, plain and simple, because it has factors to it that people don't understand. And just because you have one pressure doesn't mean that it's bad. Because it, you know, why is it that pressure? Is it high flow or is it low flow? And that's the question. So a lot of high performance, super high dollar budget, or super high, no freaking budget limit kind of engines, they try and run low pressure oil. They try and run 20 pounds of pressure through the entire operating range because they don't want to lose a little bit of work that it takes to move that oil pressure. Now, the Engine Masters episode, they showed that it hardly costs any horsepower to raise pressure. So whether that's, you know, sound or not, it would seem to me the guys with $1 million budgets for their engine program would know whether or not they need high oil pressure or not, and if they want low, then it's for a reason. So yeah, I don't know. But lower pressure might mean more flow. And in your case, it absolutely means more flow. So I wouldn't stress 5 PSI drop. SMS says King bearings are trash. I mean, they work a bit. They have their ups and downs for sure. And they've had a lot of quality control issues. Holy shit. We got some King bearings that are shaped like this weird. It was like the whole bearing was actually elliptical, but I don't know, it was bad. They just weren't bent right. And they're like, yeah, just bend them out so they stick better in the engine. I was like, fuck you. I'm not bending these bearings. Like, make them right, assholes. Yeah, so I'm not a fan of them. They've had so much quality control problems, so many design changes over the years. And, you know, and like I said, the oil pressure is lower idle than I like, but, you know, is that because I'm still semi-brainwashed into thinking that oil pressure is super crazy important? Maybe. You know, maybe it is. Do I know why the pressure is lower? No. I think it's because it dumped out the side of the mains, and if it is, then I have a worthy concern. But if it's not dumping out of the side of the mains, and somehow they're supplying more pressure to the rods, or more oil to the rods, and that's why the pressure dropped, well, then then my concerns are unfounded. But I don't think that's the case. What did I miss about the 2.3 of a 2.5? I love the feel of the 2.3. The 2.3. Trying to put this in words. The 2.3 feels refined. 2.5s feel imbalanced. 2.5s feel not just imbalanced in vibrations, but imbalanced in the whole configuration. It feels like they're just, I mean, they are imbalanced. Let's just back that up. They're completely fucking imbalanced. I mean, the EJ25 is overall a pretty shit fucking engine. In the grand scheme of things, it's a shit motor. It takes way more money, way more parts, way more everything to do what you could do with almost any other engine quite easily. Now, that being said, you can get a stock 2.5 long block into the 9s. At least Junior and what's his face did it. CJ did it. And you can't do that with a lot of other 4-cylinders. There's not built strong enough. I mean, the EJ's got strong rods in it and that kind of stuff. But overall, the geometry and what it takes to make power and what you sacrifice, mainly spool and a bunch of other shit with an EJ, it's just there's so much give and take with an EJ. The compromises are so great that the 2.5 just feels weird. It doesn't feel like an engine should. The torque is peaky and falls on its face. It doesn't carry power that great to redline. You know, it just, the whole thing feels off to me. You know, the 2.3 on the other hand, it feels refined and smooth. It sounds awesome. It carries the revs, the power, feels more linear, less peaky and erratic. Like it's a cooler feeling motor. It's a they can both be a pleasure to drive. The 2.3 is a pleasure to drive. It really is. Yeah, it's got less grunt down low. You got 100 cc's less displacement, or 100 cc's. That'd be funny. 100 cc's. Oh yeah, 100 cc's. That's right. I was thinking 100 cubic inches. That'd be something. Yeah, like it's got less displacement and the shorter stroke. And the shorter stroke means a little less torque on the bottom end. And you can tell between the 2.3 and the 2.5. But when it gets singing, it just feels really good. And I can't describe it other than that. Like you have to drive one and just feel the way they pull and how smooth and linear and controlled it is. It's really good. EJ20 feels like ignition cut after 4K. I don't know about that. Oh, they're saying your EJ20 doesn't. Can bad tension pulley affect the reading of cam sensor and crank sensor due to belt stretch, or it can't stretch that much? Let's see. The tensioner does not affect stretch. Not appreciably, at least. The tensioner's job is to make up the extra length that occurs when the belt stretches. So the distance from the crank to the camshaft is strictly a function of the strength of the belt and the load that it's under. Tension has nothing to do with it. The tensioner is just to keep the belt from jumping off of something and that kind of thing. So, no. The simple answer to your question is no. The tensioner can't affect any of that. Now, a bad tensioner can cause the belt to skip, and that definitely has problems. So, and no, after 4,000, no, the tensioner had nothing to do with that. If you were to speculate why they chose the 2.3 Tom's Mill, what would the key reason be? Because it's fucking awesome. After 4K, I don't know what you're asking me there, Yuki Tech, please, whatever that is. I'm sorry, I don't understand what you're asking me. The tensioner has nothing to do with anything associated with timing. So it's just to keep the belt from popping off. We got rods. The fuck? Oh, for Igor. Oh, okay. I was like, what? I already got my rods. Yeah, 2.3 Pastrana. Well, so Pastrana's build isn't restricted, right? It's not restricted, and that's key. If you're in a rally situation where you have a restrictor on the engine, the last thing you want is a 2.3. You don't want that. If you have a restrictor, what you want is a long-stroked, short-rodded, narrow-bore engine. You don't want what the 2.3 is. It's the opposite of the 2.3. So Vermont Sports Car makes a ton of 83 millimeter stroked EJ207s, and that's what they put in the rally cars. But if you look at rally car torque curve, it's a huge spike and then falls on its face. And generally what you get is it looks a lot like a diesel, really. And that you have all your torque and then it falls away and the horsepower is pretty flat. So like I did an Evo 4G63 that was stroked, and it did 525 foot-pounds of torque to the wheels at like 2,200 RPM. And it made 225 wheel horsepower. The torque went to the sky and fell off. Horsepower was like a flat line. Looked a lot like a diesel. And the reason for that is the stroking this setup with the short rods and everything, it allowed the turbo time to feed the engine. Now, what do I mean by that? Well, if you look at the way a piston goes up and down the cylinders with a really shitty rod ratio versus a really good rod ratio, what you see is that when the rod ratio is what's considered poor or less than ideal or just short, say like a 1.3, for example, the piston moves really slow through bottom dead center. It goes slow through bottom dead center, has way more dwell at bottom than it does with a different rod ratio. And then it moves really fast through top dead center. Whereas if you have a long rod setup, like a short stroke and a long rod, you have very little dwell at bottom dead center and a lot more dwell at top dead center.
And so each one of those is for a totally different thing, like what you want to get out of it. So the rally car, you want to slow that piston down at the bottom and give the turbo time to suck air through that restrictor and then put it in the engine. And then you want that piston to fly through TDC as fast as you can, because that energy you add with the high piston speed increases velocities and during charging at the top as well, but also exhausting, and then adds a lot of energy to the mixture, so you get a really strong combustion. And that's good for making a lot of torque. But it's bad for high RPM. And so the opposite is true with the long rod short stroke setup. You get a lot piston all top dead center, and it gives you time for other things to happen that you want to have happen to accentuate high RPM power production. So with the Pastrana build, they weren't restricted anymore. They wanted to put a fat fucking turbo on it, run the shit out of it, make a lot of power at high RPM, and have it last longer. And a 2.3 will last longer higher RPM than a 2.5 will. The piston skirt loading, the side loading of piston skirts is dramatically less. The pistons are shorter and they're lighter. The distance they travel is greatly reduced, which reduces the total forces and effects that they feel, versus a longer stroke. So the 2.3 lasts longer and does a better job making power. Yes, Kat, what do you want? I know, my camera's where your bowl normally is. So, yeah, that's why they did it, because it fucking rips. 2.3 loses the EJ feeling like you're beating it to death to rev it out. 2.3 feels, yeah, I mean, if you've driven a 207, the 2.3 feels like a 207 in that it just revs really nice and carries really good, but it makes more power everywhere. And it spools bigger turbos faster. So I had a car that was a 207. It came out of my car. I put it in a friend's car. Excuse me. Dyno tuned it. VF, the stock VF did all right. Then he blew it up, raced so much people, because he raced a lot of people. And so I did a 2.3 build for him. I used a stock piston, believe it or not. I took a stock STI block and a set of +2 pistons that I had modified to fit the stock pistons, or +2 rods and modified to fit the stock pistons. Put a 207 crank in it. Yes, hi, Kitty. Put the 207 crank in it and put it under the 207 heads. Now, that gave it a 235 with a normal compression ratio, because the chambers are smaller on the 207 head, so it's still like 8.5 to 1 or so. And then we put the twin scroll DOM15 on it. And the power curve looked just like the factory power curve, only up. And it carried better. But it was the torque peak was in the same spot and everything. So it spooled that 1.5 faster than a 2 liter would have, and everything just went up. And it was a dramatic improvement. It looked really good. B58 went slightly under square, unlike the 2JZ perfect square. B58 is probably under square because, under square is really good for spooling turbos, longer strokes, but it was a diesel block, right? So it was made for a long stroke to begin with. And cylinder spacing is important. So bore spacing is something that people don't often talk about, but bore spacing is how far from center to center of the bores. And if you have 6 cylinders, 6 times that plus shit on both ends gives you an engine length, right? So if I had a really big bore with 6 cylinders, it's gonna be a really long engine. If I got a smaller bore, it's gonna be a short engine. This engine's still to fit in cars. So a little bit's gonna be the amount of available space in the car to control engine length as well. And then the fact that it was made for a diesel, which is going to want a longer stroke anyways. And since they made that block to work for the diesel and that car, I'm guessing that the reason the B58 for the gas car is under square is more closely tied to the fact that it was sharing a block with a diesel than anything. But standard geometry engines that are slightly under square do really fucking good. All the Hondas are almost all the Hondas are under square, and they've always ripped. What's really cool too with under square engines is you have a much wider flammability window. And I know I've talked about that in some streams. The flammability window is really important. And since the B58 likes to run lean, or BMW likes to run engines lean, the wider flammability window aids in that. And having an under square engine increases that window. Now, what does that mean? That means what air-fuel ratios does the engine effectively combust? So if you take an EJ25 and you run that sucker at 15.5 to 1, chances are you're getting some misfires out of it. It's not running clean. You get into 16s, you definitely get misfires, right? It's just not going to run very good. But you take like a B16 or a B58 and you run it at 16 to 1, it's going to keep running. It's going to be fine. And under square engines typically have wider flammability windows than that. The Hemi, for example, is a lot like the EJ. Narrow window. The Hemi does not like to be too lean. It doesn't work. Hey, what are you doing? Making a lot of noise back here. So, a lot of reasons, and obviously I don't know. All of my reasons are speculation, but it just makes sense to me that it's more closely tied to the diesel engine and the desire to run it leaner, would be my guess. And also, under square engines are more efficient. Under square engines typically get better fuel economy. It's just the way it is. Flammability window is actually interesting. I'm really intrigued by it. I find it very interesting because the geometry is so important in that. And so far what I've figured out with it is it really has to do with how compact and close everything is at the time that the ignition event happens. So if I have a really big chamber and a really big bore, then everything's really spaced out in there. And if I try and light it off, the chance of me getting, a good initial burn is reduced because everything's spaced out. And then if I do get an initial burn that's good, the chance of it propagating throughout the cylinder to all the other molecules that are in there spaced out a lot is also reduced. But if I take that chamber and make it more compact, I take that same volume and squeeze it into a smaller space, or even into the same volume, but into a narrower tube where everything is kind of forced to be closer together. So instead of a big flat pancake, I take, we'll say it's a 57 cc chamber. On an EJ, it's a dome chamber. It's pretty wide. But then I take a 57 cc chamber on another motor and I do this with it, or make it more round or whatever and get it all more closer together, and I shorten the distance between all those neighboring molecules. That flame is more likely to propagate, the combustion propagate to the closer molecules than they were than the further ones. So, and it has a direct effect on how well the engines can burn other AFRs. Also, turbulence has a big effect as well. If the cylinder has enough turbulence and quench, or the intake valve, the port is in such a way that you get a lot of swirl or tumble or whichever direction that they're going for. If you get a lot of turbulence and get a more homogeneous mixture, that helps as well. It's harder to get a homogeneous mixture in a big chamber. I don't know about that. I mean, maybe a little bit. I would say a little bit because it doesn't have to be, what should I say? Not in the rod ratio sense. Let me start with that. Not in the rod ratio sense, because the B58's got a way better rod ratio than EJ255 or EJ25 does. That's a function of the bore to stroke ratio. That's the underscore aspect of it again. As the piston moves down the cylinder, for every degree, how much of the displacement are you adding to the chamber? And you get, trying to figure out how to say it. You can add displacement straight down, right, in a narrow column, and that keeps everything closer together, closer to the center. Or you can go from a chamber and then you pull it down a little bit and then boom, there's this big volume below it, right, in the cylinder. And you're adding volume that's very wide. And that affects how well that flame, because it wants to go and propagate. If you give it a nice tight barrel shape to propagate down, you're going to get good distribution. If you release into this big open vastness of a large cylinder, then it can be, it's not as well guided, just like a barrel on a gun. If I have a nice, tight, clean, long barrel, I'm directing the flame and the propagation goes down the chamber. It's all nice and controlled. But if I have this you know, giant void that I'm trying to have this burn propagate into, like which way is it going to go? If I have this huge chamber or this huge bore, you know, it can go this way and then do this. How is it going to propagate in there? Can it get off on a tangent and do these numbers? Whereas if I have it tight and compact and long and cylindrical, then that burn is going to be more closely regulated as it goes down the chamber. That's the best I could describe it. So it's not necessarily dwell, because again, that longer rod is going to have better dwell than the 257, and the 2.3 does not have an improved flammability window over the 2.5. At least not that I've noticed. I don't notice the 2.3 having a better flammability window than the 2.5, and they have drastically different piston dwells. So I don't think that the dwell itself is going to be a function as it would pertain to rod ratio. But I could be wrong. I don't know where in the new book flammability window is. I had this book here. This is the second edition. I like this one. It's I had the first Paul Yaw from Jet Dynamics. He gave me the first version many years ago. I think it was 2012-ish, maybe 2010. It was a long time ago. Fuck, maybe longer than that. Maybe it was 2009. Well, regardless. So he gave me the first generation of this book, and it was made in like the early 80s, but it had research from like the 60s and past, and it wasn't all up to date. But the second edition is very much up to date, and it's in a better format. I like it better. You definitely can go through the book, and it's very much it's more lesson related for sure. It definitely comes across more like a college textbook than the first one did. So I really like it. Is your cylinder forward good connection? I wouldn't. No, I wouldn't put it there. So I put it there during testing. So that connection in the back of the head is where I put a port and the temperature probe. The idea was to figure out how much different that area was inside the engine versus everywhere else, right? The whole reason I got the cooling mod is because I looked at the engine design. I said, hey, there's a low flow region through this whole side of the head. Just looking at the design, saying, you know, that's my hypothesis. Now let's see if it's true or not. So I put temperature probe in the head, on the front and the back, and the main coolant jacket and all of that, and then I ran tests on it, and sure enough, that area was way hotter than everything else that I tested. It's often lower than the bulk coolant temperature, the average coolant temperature in the crossover pipe, but by a much lower margin than everything else. So it's way closer to the average coolant temp. And in long pulls, the area got hotter than the average coolant temp, which was like, you know, absolutely a dead giveaway that it was a low flow region. It was heating up in that spot more. And then when I put the cooling mod on the cars, I also tested since I couldn't put a temperature probe in there anymore because the cooling mod was there, I did surface temperature tests, and just the surface temp of the head was changing 5 to 10 degrees by opening and shutting the mod. So that showed that the coolant was definitely flowing through the area with the mod there, and not very well with the mod gone. So I would not put one there to regulate the engine, because that's not representative of the rest of the engine. The rest of the engine is better represented by the average temperature in the crossover pipe, because the water temp is part of multiple compensations, right? Fueling and timing and everything else. So you want to know what the water temp is, the average temp for most of the engines, so that the compensations are based on all the other cylinders, not just cylinder 4. So no, I wouldn't think that's a good place to put one for running the engine. If you're trying to see how much higher it is and how shitty of a spot it is, yeah, feel free, check it out. It's your shitty spot. It needs more flow, which is why I put the cooling mod on there. Start pouring the stream chat, whatever. Well, no, you're not going to borrow this book. You're going to buy your own. This book's 200-something bucks, and I reference it too often to loan it out. I know they have PDF versions that you can get. I might even have a PDF version. I think I had a PDF version of the first one. actually. And the first one I got is signed by Paul. He was really important in my tuning knowledge and growth. He was an important person in that. And I've sent him love letters telling him thank you and that kind of stuff, but he hates that shit, so he doesn't respond back. I think it was like Father's Day or something. I was just thinking about, oh, no, it was Thanksgiving. That's what it was. It was Thanksgiving. I was feeling thankful for a bunch of things that happened in my life and people that have influenced it in good ways, and he was one of them. I sent him a letter or a text message just saying thank you for all the help that you've done and the guidance that you provided me, and I wouldn't be where I am today if it wasn't for your help. And he didn't respond. I'm sure if he did, it would just been like, fuck you, Dom. A loving fuck you, of course. Let's see. Flame propagation process. Flame propagation process. Laminar, premix, rapid burning. I don't see it in here. They might not even call it that in this version of the book. It might have changed the name for it. Well, the version 1 book probably. I have it in here. It's still in a box. I think the first edition is still in a box. I'm more familiar with everything in that one. Anyways, I'll have to look for that sometime. Okay. This light on the walls here is killing my eyes. It's way too bright. And I need to do a bunch of shit. It's 2 o'clock. I haven't had a thing to eat today. So I need to get some food in my belly and return some phone calls that I missed while I was doing this. Ashton has a PDF of both of them. So if you're in the Discord, you know, Matt, you keep saying you need to go to the Discord. So let's say you gotta go to the Discord now. So deal with it. Anyways, guys, hey, thanks so much again. I like the pump. I like what they did. I wish they'd greased it like I said they did, and I'm sure they probably do the rest of them. And I'd like to see this area open up a smidge more right there, and maybe this radius a little better right here coming out. Those are my only points where I would say this thing could be improved. Overall, it's a very good representation of what should be done to make the pump better than the factory pump. They use a great factory core. They treat the gears really nice. They got it shimmed up properly or aggressive enough. The relief is done really good. So they did lots of good stuff to this pump. And I think it's a good pump. Like I said, this is going to go on my next build. I'll be running 2.3 at like 9,000 RPM or so for S&Gs because it's fun and it feels good. It'll have a G35 900 on it and our low mount kit and the air water intercooler. And all that. Eventually I'll have a dry sump too. And the plan is to stick the air water intercooler in the dry sump in the engine bay and have it all be compact and working and everything else. So we'll see how well that goes. We're also talking about doing a 6-cylinder in a car because I love 6 cylinders. The H6, any 6-cylinder really that rips, has a nice header design, is basically ear sex. And I like Subarus with 6 cylinders. And since it's really easy to do the swap, we're going to do one just to show how fucking easy it really is to do. Because other people would have you think that it's this long, drawn-out, difficult process, and it's not at all. Especially if you have a GR or VA, it's really easy. And we're going to show that at some point. So not sure when that point's going to be, but yeah, sometime. Dry sump, I said, is being made right now. Battery tie downs are being made right now. If you don't know about the tie down, it's really a quality of life improvement. If you haven't seen it, it makes it way easier to attach the J bolts and to the whole thing. Bloop, screw down. It's super easy. You'll get to see that in demo when it comes out. I also have some dress up parts coming out. There's only that I haven't really talked about much because I don't really do a lot of dress up stuff, but this one I think solves the problem, just like the battery tie down solves the problem. This other part solves the problem as well. So stand by for those. And damper testing is still ongoing. I just was run out of money for a while, so I had to stop because I have all these other projects going on too. And then I will go on with that some more. I got to change the bypass rates and make the damper freer to move. I had it really tight. It's too tight. I'm going to loosen up some of those chambers on the flow paths, open that up. I should get more damping effect at higher RPMs. Worked really good at idle. Like it is set right now. Very, very good. But I want to work better at higher RPM than just idle. And then, what else? I think that's it. That's it, guys. So, again, all my shit's available at GetaDomTune.com. Cooling mods are going to be back in stock again pretty soon. I think I have some. I think 4, maybe. Might have 4 left, and that's it. But I just got a bunch of stuff today, so we'll start putting those together this weekend. My wife, who's my main assembler, she's been sick. I think she got the COVID again. Probably Omicron or some shit, I don't know. But she is feeling a lot better today, and so that means that we'll start building some kits and shit again here really soon. Other than that, and I'm going to be doing, as soon as I get one of the other projects done, a custom piston and rod combination that features things that no other Subaru rods currently feature. And obviously the pistons have to match the rods because of what I'm doing. It makes them way stronger, and it's gonna be cool, stronger and lighter. So that's gonna be awesome. Whenever I get around to finishing that up, but like I said, I got to finish the other projects, and my next batch of cams was supposed to be here a month and a half ago, but FedEx fucked up and sent them back to New Zealand. So I'm waiting for those to come in too. So if you're looking for cams, that's why I don't have any, because FedEx gave me the big old boop. And that's it. So thanks again, guys. Have yourself a good week. Hope if you're at home right now enjoying the holiday, have a good holiday. And yeah, I had a dream.